These are the analyzing graphs of functions notes. Alright, we're going to be looking for where the graph is increasing and decreasing. Okay, you read a graph from left to right, just like we read in English. Okay, so from left, starting at the left, looking towards the right, okay, is the graph going up or down? So looking at this example here, we have this part saying it's decreasing, and that's because from start to here, that graph is going down from left to right. So that's decreasing. This chunk in the middle is called constant because it stays the same. It's not from left to right, it's not going up or down, so that's considered a constant. Okay, this last section here is increasing. That's because from left to right, this graph is going up. Okay, so we would say that this graph is decreasing from -2 to 0. Okay, because we're reading from left to right, we're using x's and not y's. Okay, then we would say that it's constant between 0 and 2. So between 0 and 2, left and right, it's staying constant. Then we would say it's increasing from 2 to 4. So from 2 to 4, the graph is going up. Okay. All right, this says describe the increasing or decreasing behavior of each function. Okay, so this function from left to right, if I start here at the left, from left to right it's going up and up and up. Not quite as dramatically there, but it's still going up and up and up. So this entire function is increasing. It is increasing the entire way. It is not decreasing at all. So we would write this, because there's arrows here at the edge of the graph, okay, we would say this is increasing from -infinity, since there's arrows on this side, to infinity. It is increasing from the left to the right forever. It's always going up. Okay. All right, describe the increasing or decreasing behavior of the function. Okay, so again, on your notes, these are arrows here, which means that it's going up and down forever. Okay, so starting at the left here, okay, it's increasing to this point. So this part in red here is increasing from -infinity to -1 here. That chunk is increasing. Then from -1 we start to go down till we hit this chunk. From -1 to 1, that blue chunk is decreasing. It's going down from left to right. So we would say it's decreasing from -1 to 1. And then this last chunk, from left to right, we're going up. We're increasing. Okay, so we're increasing again, starting at 1 and going till forever. Okay. All right, it says describe the increasing or decreasing behavior of the function. So again, from left to right, from starting at the very left of the graph, we're moving up till we get to 0. Okay, so because of this arrow, we are increasing from -infinity till 0. Since 0 is on the graph, we're going to use the less than or equal to symbol. Okay, there's no open circle there or arrow there. This middle chunk is not going up or down. It is staying the same. So we would say that's constant. So it stays constant or plateaus there, and that happens between 0 and 2. Okay, so it is constant between 0 and 2. Then this last section from left to right, this is going back down. Okay, so starting at 1, it starts going back down. So decrease from 1 till forever, which is infinity. Alright, so now we're going to talk about minimum values of the graph. The minimum of a function is the lowest point on the graph. So looking at this picture, your lowest point, this is the lowest part of that U. Okay, so since this lowest point is at -3, we would say the minimum is down at -3. Since minimums and maximum are talking about height of the graph, the highest and lowest points of the graph, then you look at the y values because y goes up and down. Increase and decrease, we're reading the graph from left to right, so we're using x values. Alright, maximum functions is what it sounds like. A maximum function is the highest point on the graph, which makes sense. Minimum is lowest, maximum is highest. Okay, so on this graph, the highest point in this graph is right up here at the top of the hill. So the maximum value of this graph is 4. This graph does not have a minimum. Okay, because it goes down forever and ever and ever, there's no minimum. The previous graph had no maximum because it went up and up and up forever. Okay, so the maximum of this particular graph is 4, and there's not a minimum. Alright, sometimes there is no true minimum or maximum. Okay, so in this example, this graph is going to go up and down forever and ever and ever and ever. So there's no actual maximum or minimum. It's going to go up forever, so it won't have a maximum. And it's going to go down forever, so it won't have a minimum. So sometimes, since this is where all the squiggly stuff is happening, this is where all the action is, they'll say, what's the relative maximum? What's the relative minimum of this area? Okay, and these are the relative maximum and minimum. So this would be a relative maximum, this would be a relative maxima, this would be a relative minima, and this would be a relative minima. It's not the actual true minimum, okay, but of this area, of this chunk, those would be relative maximums and minimums.